Welcome to the Deep Dive. Today, we're going to be diving into the fascinating world of AI and how it learns.
Oh, yeah.
You might be familiar with the concept of machine learning,
Mm.
but have you ever wondered, what's happening under the hood? How does AI go beyond just memorizing facts and actually learn to apply knowledge in new situations?
No,
That's what we're going to explore today.
that's right. It's like the difference between a student who crams for a test and one who truly understands the material.
Right.
One just regurgitates information, while the other can use that knowledge to solve new problems.
Yeah.
In AI, this ability to adapt and apply learning to new situations is called generalization,
Okay.
and it's a key challenge in the field.
So generalization is the goal.
Yeah.
But how do we get AI there? What are the training methods that researchers are using to develop these super adaptable AI systems? We're going to unpack some cutting-edge research that compares two popular methods, supervised fine-tuning,
Yeah.
or SFT,
Yeah.
and reinforcement learning,
Mm-hmm.
or RL.
Imagine you're teaching a dog a new trick.
Uh,
With SFT, it's like giving the dog very specific commands and showing it exactly what to do. With RL, it's more like setting up an obstacle course and rewarding the dog for figuring out how to navigate it. Both methods can lead to learning, but they work in very different ways.
I like that analogy. And the research we're diving into today suggests that one of these methods, RL, might be particularly good at fostering generalization in AI. To test this, the researchers used some really creative examples, like a card game called GeneralPoints and a virtual navigation challenge called V-IRL. They actually had AI play games and find their way around virtual cities to see which training method led to better learning and adaptation.
Yeah, the researchers use something called foundation models as the basis for their experiments.
Mm-hmm.
Think of these as large, powerful AI models that have been trained on massive amounts of data. They're like the foundation of a house upon which you can build more specialized AI systems.
Okay, so it's like these foundation models already have a good general understanding of language and concepts,
Right.
but they need further training to become experts at specific tasks. And that's where SFT and RL come in.
Exactly. SFT is like giving the AI a detailed set of instructions and a ton of examples to learn from. It's very direct and controlled. You're telling the AI exactly what you want it to do. RL, on the other hand, is more like giving the AI a goal and letting it explore different ways to achieve it.
So in the card game, the AI might have to figure out how to use 4 cards to reach a target number. With SFT, you'd show it specific examples of winning combinations. But with RL, you just give it the rules and let it try different strategies, rewarding it when it gets the right answer.
That's right. And in the virtual navigation task, the AI had to follow instructions to navigate to a specific location in a virtual city. With SFT, you'd give it a set of directions and show it the correct path. But with RL, you just give it the destination, let it figure out the best route, rewarding it when it gets there.
So the researchers set up these challenges, trained the AI using both SFT and RL, and then sat back to watch how they performed. But they didn't stop there, did they? They added a twist to really test the AI's ability to generalize. But tell me about the variations they introduced.
Yeah, they wanted to see if the AI could adapt to situations it hadn't encountered during training. So they came up with 2 types of variations, rule variations and visual variations. For the card game, a rule variation might be changing how face cards are valued. For the navigation task, it might be using different types of directional instructions, like turn left at the blue building instead of turn left at the second intersection.
Okay, so they're basically tweaking the rules of the game to see if the AI can keep up. What about the visual variations? Those sound intriguing.
Remember, this was a vision language task, so the AI had to process both text instructions and realistic images. In the card game, a visual variation might be changing the color of the cards. In the navigation task, they tested the AI in different virtual cities with different layouts and landmarks. The idea was to see if the AI could still navigate effectively, even when the visual environment was unfamiliar.
I'm on the edge of my seat. So which training method came out on top in this battle of the AI brains?
Well, the results were pretty clear-cut. Across both tasks and all those clever variations, RL consistently outperformed SFT in terms of generalization. It seemed like RL truly enabled the AI to grasp the underlying principles of the game and the navigation task. The RL-trained AI could adapt to changes in the rules and the environment, while the SFT-trained AI often stumbled when faced with anything new.
So RL is the clear winner when it comes to generalization. But why? What's happening under the hood that makes RL so much better at fostering this adaptable learning?
That's the million-dollar question. And the researchers uncovered some fascinating insights that might explain why RL shines in this area. But before we jump into that, let's take a moment to make sure everything is crystal clear for you. Is there anything you'd like to recap or ask about before we go deeper?
Actually, yes. I'm curious about the role of SFT in all of this. If RL is so great at generalization, does that mean SFT is useless?
Not at all. While RL might be the star when it comes to adaptability, the research suggests that SFT still plays a crucial role, especially in the early stages of training. Think of it as laying the groundwork for RL to really take off. But we'll dive into that more in the next part of our deep dive.
Okay, so stay tuned, folks. We're about to uncover the secrets of why RL might be the key to unlocking truly adaptable and intelligent AI. We're back, ready to delve deeper into the mystery of why reinforcement learning seems to be the key to unlocking truly adaptable AI. We left off with a cliffhanger. SFT still has a role to play, but how?
Well, the research suggests that SFT helps to stabilize the AI's output format,
Okay.
ensuring that it communicates in a way that the RL system can understand. It's like making sure everyone is speaking the same language before a big brainstorming session.
Ah, so SFT is like setting the stage for RL to come in and really shine. It provides a solid foundation of understanding and communication. But you mentioned earlier that the researchers uncovered some pretty interesting insights into why RL might be so good at fostering generalization. What were some of those aha moments?
One of the most fascinating findings was that RL, especially when combined with an outcome-based reward, actually improved the AI's visual recognition abilities in the virtual navigation task.
Wait, so not only was the AI learning to navigate, it was also learning to see better in the process. How does that even work?
Well, it seems that by focusing on reaching the destination,
Right.
the AI was actually becoming more attuned to the visual cues in its environment. The reward for successful navigation was driving the AI to pay closer attention to what it was seeing and learn to use those visual cues more effectively.
That's incredible. It's like the AI is developing a deeper understanding of the relationship between what it sees and what it needs to do. Are there any other key findings that help explain RL's success?
Yeah, the researchers also discovered the importance of what they call verification steps. These are moments during the training process where the AI can pause, reflect on its actions, and receive feedback.
Mhm.
They found that scaling up the number of these verification steps led to better generalization.
So it's like giving the AI more opportunities to check its work and learn from its mistakes. The more feedback it gets, the better it becomes at adapting to new situations.
Exactly. Think of it like learning a new skill. The more you practice and get feedback from a coach or a teacher, the better you become at that skill. It seems that the same principle applies to AI training.
Okay, this is all incredibly fascinating from a technical standpoint, but I think our listeners are probably wondering, what does this mean for me? How could these research findings actually translate into real-world applications?
That's the exciting part. This research isn't just about theoretical advancements in AI. It has the potential to revolutionize various aspects of our lives.
Yeah.
Imagine a world where AI can not only follow instructions, but also learn and adapt on the fly, just like humans do.
Now you're talking my language. But let's get specific. How could this type of adaptable AI be used in, say, healthcare, transportation, or even the arts?
Let's start with healthcare. Picture an AI-powered medical diagnosis system that can analyze a patient's symptoms, medical history, and even genetic data to come up with potential diagnoses that a human doctor might miss. Not to replace doctors, of course, but to augment their expertise and potentially lead to earlier and more accurate diagnoses.
That would be a game changer. What about transportation? Self-driving cars have been a hot topic for years, but they still face challenges in unpredictable situations. Could this research lead to safer and more reliable autonomous vehicles?
Absolutely. A self-driving car trained with RL could learn to adapt to things like sudden weather changes, unexpected road closures, or even the unpredictable behavior of other drivers. It could constantly learn from its experiences on the road and continually improve its driving skills.
So we're talking about an AI that can think on its feet, learning from both its successes and its mistakes. What about the arts? Could this type of AI be used for creative tasks?
That's where things get really interesting. Imagine an AI that could collaborate with artists, musicians, or writers, helping them to explore new creative avenues, generate novel ideas, or even create entirely new art forms. Think of it as a creative partner that can analyze vast amounts of artistic data and identify patterns that humans might not see, leading to unexpected and inspiring breakthroughs.
Okay, you've officially expanded my horizons. But let's be realistic. While the potential benefits are enormous, AI, especially AI that can learn and adapt so effectively, also raises some important questions. As this technology continues to develop, what are some of the challenges we need to be thinking about?
One of the biggest challenges is ensuring that these AI systems are developed and deployed responsibly. As AI becomes more integrated into our lives, we need to be mindful of its impact on society and make sure that it's used for good.
So it's not just about making AI smarter, it's also about making it beneficial and aligned with our values.
Exactly. But remember, this research is just the tip of the iceberg. There's still so much to explore and discover in the world of AI.
Well, I, for one, am eager to continue the journey. Are you ready to dive even deeper?
Let's do it.
We've been on quite a journey exploring the world of AI and how it learns, specifically focusing on this exciting research that suggests RL might be the key to unlocking truly adaptable and intelligent AI.
Yeah, it's been fascinating to unpack these findings
Mhm.
and consider their implications. We've talked about AI that can diagnose diseases, navigate complex environments, and even push the boundaries of creative expression. But it's important to remember that this research is just one piece of a much larger puzzle.
Right. We focused on SFT and RL, but there's a whole universe of AI research happening out there. What are some other promising avenues that you think are worth paying attention to?
Well, the field of AI is constantly evolving, with researchers exploring new approaches all the time. One area that I find particularly intriguing is meta-learning,
Oh, wait.
where AI systems learn how to learn instead of being programmed for specific tasks. These systems can adapt and acquire new knowledge much faster and more efficiently. Imagine an AI that can learn a new skill with just a few examples, much like humans do.
That's mind-blowing. So it's like AI becoming more self-sufficient in its learning process, constantly evolving and expanding its capabilities. What other areas of AI research are you excited about?
Another area that holds immense potential is transfer learning. This involves training an AI system on one task and then applying that knowledge to a different but related task.
Yeah.
For example, an AI that's learned to recognize objects and images could then use that knowledge to improve its performance in a self-driving car, where object recognition is crucial.
So it's about leveraging existing knowledge and making AI more versatile and efficient. It seems like the future of AI is all about developing systems that can learn and adapt in more human-like ways.
Precisely. But as we venture further into this uncharted territory, it's crucial to approach AI development with a sense of responsibility. We need to consider not only the technical advancements, but also the ethical implications of creating AI that can learn and adapt so effectively. As AI becomes more integrated into our lives, it's essential to ensure that it's used for the benefit of humanity.
That's a powerful reminder. We've talked about the incredible potential of AI, but it's equally important to address the potential challenges and ensure that AI is developed and deployed in a way that aligns with our values.
Absolutely. Transparency, accountability, and fairness are crucial considerations. As AI systems become more complex, we need to ensure that we understand how they work, that they're used responsibly, and that they don't perpetuate or amplify existing societal biases.
It sounds like there's a lot to consider as we move forward with AI development, but despite these challenges, I can't help but feel a sense of excitement and optimism. We're on the cusp of a technological revolution that has the potential to transform our world in unimaginable ways.
I share your enthusiasm. AI has the potential to solve some of the world's most pressing problems, from climate change to disease eradication. But it's up to us to ensure that we harness this power responsibly and ethically.
Well, folks, we've covered a lot of ground today, from the intricacies of AI training methods to the potential benefits and challenges of this rapidly evolving technology. We've explored the power of RL and gotten a glimpse into the future of AI, where systems can learn and adapt in ways that were once considered science fiction. It's been a fascinating deep dive, and I want to thank you for sharing your expertise with us.
It's been a pleasure. And as always, I encourage everyone to keep learning, exploring, and engaging in these important conversations about the future of AI.
That's right. The future of AI is a story we're all writing together. So stay curious, stay informed, keep diving. Until next time.